Hello, everyone. Hello, everyone. And so welcome to our data visualization meetup, number 12. Thank you so much for participating to, to our meetup. Hello, everyone. Hello in the chat. So first of all, I am Luc Guillemot. I am an interaction engineer at Interactive Things, and I organize this meetup with Benjamin Wiederkehr, who is also with us tonight, who will like monitor the chat. And we organize this meetup, Data Visualization Zurich, to provide a space to share and advance the knowledge about data visualization in our local community in Zurich. Usually it happens at Interactive Things in our studio in Zurich, Kreisvier. But like because of the pandemic, we do it online currently. Yes, so before we actually dive into the subject for tonight, just a few logistics points about using Crowdcast. You probably see below the video feed, there is a button, ask a question. So if you want to ask a question, that's how you can do it, clicking there. You can ask a question anytime during the event, and we will probably address them at the end of the presentation. You can also upvote questions posted by others if you want to, if you think these questions should be answered in priority. So now about tonight, we have the honor of having with us Yannick Rochat. So thank you very much for for being with us tonight. So Yannick is
Sorry. So thank you very much for the invite.
Of course. Yannick is a lecturer at the University of Lausanne in the Game Lab study group. And he studies networks of characters in fiction and the relation between games and code. And he also teaches game studies and data analysis at the University of Lausanne. So we thought it's like a really like a great topic to study video games. So Yannick accepted to share with us some knowledge about how data visualization are used in video games, and maybe what we as practitioners of data visualization we can learn from game designs. So thank you very much, Yannick, already. So about the agenda for today, Yannick will talk for about 40 minutes, and it will leave us about 20 minutes at the end for your questions. So don't hesitate to ask questions whenever you have something in mind. Yeah, then I think Yannick, I will give you the stage now.
Okay, thank you very much. So yeah, feel free to ask questions, and maybe Benjamin and Luc will catch me if there's anything, because if I understood it well, when I'm using the slides, I cannot see the chat. So thank you very much for hosting me, for welcoming me, and also Luc and Benjamin for inviting me to talk about this topic. This is something I've been wanting to cover for a long time, and never found the time to. By studying this and gathering resources, I discovered that all the original ideas I had, in fact, I had read them before, There are tons of really interesting and relevant references, and I put some links at the end of this presentation, and I'll be happy to share the slides if you want to explore more this topic. Just about myself, I've been studying mathematics at the PFL, and then I did a PhD in humanities and social sciences at UNIL. I always wanted to study both, and finally I entered the field of digital humanities, and from there the field of game studies, which is in fact the perfect topic for me because I can study math, computer science, narratology, design, game design, and video games are really at the intersection of many of the topics which interest me, but also many of the topics we study at the university. It's very, very diverse. And this topic in particular, data visualization, is really broad. There are many ways to cover it, and it's something you can see in the literature. So I'll be sketching some things at the beginning. So here is my table of contents. I'll be sketching some of the studies that are being done, and I'll be more focused on the visualization, so the charts, the design itself appearing in the games. So we'll talk a bit about the kinds of visualization that are being used in the games and how it evolved over time. So it's going to be quite short. The topic is broad, but we don't have much time. So this is something, a bit sketchy, and if needed, we'll be able to discuss that if you have a question or later. I'll be talking about the diegetic versus non-diegetic problematic. This is really interesting for the future of data visualization in games and outside of games. Some influences, which we'll see that later, and some bonus examples. One thing that Elijah Mix, who is a data analyst, maybe some of you know him because he's quite famous. He did 2 blog posts about data visualization in games, and one of the things that motivated him to do that, he loves to play games, but more than that, it's that the data visualization in games are made in such a way that they touch really broad audience. You have to be able to read them really fast. You don't have to be someone who loves data journalism, someone who loves visualization, statistics, data analysis in general. You have to be able to understand that really fast and be efficient. And we'll see that some of these visualizations, they remain really simple, and some of them are really more complex, and it's related to some kind of games. So let's start. There's a field called human-computer interaction, which is really old, more or less as old as computers. And in this field, they've been interested, at least from 1981, by the game design, the use of games, and how to communicate things in games in a ludic way, to borrow knowledge from that, to use it for interfaces and the use of computers. For example, with this paper, or with the work of Schneiderman, who in particular, so the reference is, I can give you the paper. Maybe I could create a folder if you want to see the references. He said in particular, somehow the game designers have found a way to get people to put coins into the size of computers. So this is 1983, and it's quite revolutionary to work on the computers which are very raw. What you have on screen is something quite minimalistic, and at the same time, at the arcade, people are spending so much money with the video games. So there was this hint that there was something to do. So in particular, the strong attraction of these games contrasts markedly with the anxiety and resistance many users experience toward office automation equipment. So what we are doing today, somebody was already thinking about it 37 years ago or even more. So it's something which has history. There's a lot of literature on that. And it's interesting to see how time goes and the things evolve. So this was about human-computer interaction. There is another thing that I won't cover in this talk. It's game analytics. Game analytics produce so much data, and there are so many ways to visualize them and to create dashboards. For example, if you are a developer and you want to gather data on your game for the quality assistance, so before you produce it, or after you produce it, if it's a game as service, a game which is played continuously, like Pokemon Go or Fortnite. But also, if you are organizing esports competition, you will want to be able to provide data live to your spectators, and this is a huge market. There's a lot of knowledge and a lot of literature on that too. So there is this reference which is really important, game analytics, and many stuff which is made by private companies. Here on the right, you can see some beta testing of a game. Maybe it's Assassin's Creed, I don't remember. It's a Ubisoft game. And you can see all the people who understood how the game works. So they jumped and they fly and reach the other tower on the other side on the left. But two of them, they just failed to understand what they had to do. And with this kind of techniques, they were able to understand what works, what doesn't work, how to change the level and the game design. Okay, so this is something I'm not going to cover, but these are maybe the most beautiful visualizations you can get with video games. So this is an attempt as a typology. There is an awesome article by Brian Bowman, which is 8 years old, the article, which has a really awesome typology, and I invite you to go read it. We're going to just sketch a few things. In particular, the health, the life bar. Most of the visualizations are about the status of the avatar or the different characters. So the health bar goes back quite a long time, also with the lives counter. Here you have examples of Space Invaders, The Legend of Zelda, and Mario. So you need to be able to understand what's happening in the game, because games are models of real life. Most of the time, it's the same physics laws, it's the same shapes of living persons, and you're gonna understand how the world works, but you don't have the feelings, you don't have the inputs that you have in real life. You cannot smell things, you cannot know that there is a pain happening. So you need a lot of indicators to be able to understand that. And so video games models, they model the world, but they also need to model all the physics, the relation with the environment. So that's why all these elements, the health bar and other status elements, they appeared quite early in video games. But starting from that, you had nice iterations. So you are into the game and you try to do something diegetic. So you try to have your status visualization elements happening in the game. So being consistent with the game itself. So here you have this example with a GoldenEye, where when you want to gather information and especially know how much health you have left, James Bond brings the clock close to his eyes. You also have, so we had really simple examples earlier. So here you can see that you have many health bars, you have a super bar, you can do combos. Everything can can become very complicated, and in some cases you will have a lot of informations on the screen, but it's still the same idea. You need to know how much health your character still have. And you have other iterations, other ways to represent this status. So I'll show some charts, some maps, some scatter plots later. But here it's interesting to see how, in the environment of games, you try to do something coherent with the narrative. So here you can see the face of the character. On the left, he's healthy. He has 76% of health left, and on the right, he's been bitten pretty bad, and he has very low health. And this is something you will immediately recognize from his face. So this is a way to, if you don't have time to read the health, you can read the face and understand if you need to get cover or if you can rush the enemies. So this is a way to convey information quite fast and efficiently. And this is up to you to decide if it's a good choice. But in more recent games, in more recent 3 years, we adopted another way to look at games, especially with the Dark Souls series, which are games which are really difficult. They are difficult to manipulate. The enemies are really difficult to beat, and we accept nowadays, or we want nowadays, to have really difficult experience with games. So this is an example here with Call of Duty, where you wouldn't do that 20 years ago. Here you get shot a few times, and instead of having just a picture of you getting beaten or a health bar going lower, you have all this blood splattered on the screen, and it makes the game less playable. Usually there are tricks to help you without telling you. So avoiding the bullets or avoiding the enemies to shoot. The goal here is to immerse you, to bring you deeper into the game experience. I don't really like it, but I think it's very interesting to test that, to know that still in 2018 we are still experimenting with things. We will see other examples of experimental visualization of this kind in really huge game productions. So now I'll be talking about maps, which are, I think Elijah talks about it a lot, because maps are really one of the elements which comes back the most in video games with the health bars. So this is this is the core example of maps in video games, but also of all kind of data visualization in video games. This is Simcity above, and Simcity 2000 below. Maybe some of you have played that a few years ago, but you are the mayor of a city, and you have to deal with everything: energy, pollution, police, schools, in particular. You need to play. You need to build roads. You need to play with taxes, and you have all these charts, these maps to help you take decisions. So something which is not that funny in real life. So going to the website of your city or your country and watching all these reports and reading charts. I mean, I guess all the people here are interested in doing that, but we're talking about really wide audience of people who don't know about statistics. And here you have these games which had a lot of success. And recently there was an article showing that SimCity was not only about these few SimCity games we played, but they were selling a lot of SimCity iterations to public companies, to cities, to states. with really local context. So at one time in history, there were tens and tens of SimCities, different SimCities, that were being used to introduce people to simulation, city simulation in particular. It's a bit difficult to think about that today, watching these screenshots, but yeah, that was 30 years ago. So hopefully things evolve. It's difficult to play SimCity, I mean the original SimCity today. And today the reference is a City Skyline game made in Finland. And it's the same idea, but with beautiful graphics and really accurate data visualization techniques. Here on the left, on the top, you can see the network of public transport. Below on the left, you are choosing where to put a school, and you can see the area which is concerned by the school. On the right, it's about people being happy in their neighborhood, and you will have tons. I mean, you have to play this game if you like dealing with urban studies and you like visualization, because it's really beautifully made. And myself, I'm planning to do a project, to ask funding to do a project with the city using, in fact, this game to simulate the project of the city, because I think it's really up to date. It's really, they do it right to communicate. So we are talking about maps. You also need in video games the concept of mini-maps. So you need to be able to wander and to know where you are in the universe of the game. So here on the left, it's really interesting to see that in 1989 we were trying such crazy thing. Sorry, you have the minimap on the top, on the left of this game, Populous. You can see where you are. Hopefully today we have more efficient things. Here it's the example of StarCraft II. It's a game where you have to manage some resources, and with the resources you gather, you can create soldiers and attack another bases. It's one of the main esports, so there's a lot of competition on this game, and it's a game where you have to be able to make decisions, take decisions really fast. And the mini map is something which is really well done. I mean, you need to practice a bit, but in this case, you can see here on the left where you are. So the character has his or her bases on the top right, and you will send scouts to be able to see what's happening there. And then you will, with the mouse, you'll be moving a bit everywhere on the map, going back. This is a quite old screenshot, so the screen was a bit smaller, but still, it really worked, and it helped the game have a lot of success. And these are the kind of examples that I like the most. Once again, the diegetic map. So it's the map of the game which is not outside. If I go back one slide, here, you don't know where you are. Usually we call that a goat game, because you are above it, you are flying in the sky and you see everything and you have a lot of information. And you have this map which is there on your dashboard. But here in this case, in this kind of games like Far Cry 2 and some other games we'll see later, the idea is to make you forget that you are playing a game, make you forget that you are at home, and bring you into the game. And this is beautifully made here with the Far Cry 2, which has been cited a lot for that. It's that when you want to see where you are, the character in the game gets the map. It's like the watch of James Bond before. You have the map in the game, you don't leave it. So this is the kind of trick which is quite well made here. We'll discuss it a bit later. I call it section data frames because you know what it is, and maybe you recognize here what's happening. These are character sheets of in role-playing games, where you have tons of numbers to describe characters, persons, different properties. And yeah, I think it's I don't remember who said it, but role-playing games are kind of spreadsheet games. In fact, you have to optimize how your characters evolve, and to be able to do that, you will need a lot of ways to deal with the information. In some cases, it's not well visualized because the numbers themselves are the visualization. I forgot to put a slide on that. I had the intention to, but I forgot. If you play the last Final Fantasy games or Xenoblade Chronicles games or Monster Hunter games, you are fighting with huge swords and against huge creatures, dinosaurs. And you fight them, and you have other characters fighting them at the same time. And on the screen, you have numbers popping up in all directions. You cannot do anything with that. You cannot count them. You cannot be sure that the computer made the good calculation. It's difficult to understand how well advanced you are in the fight. No, the goal is just to make you realize that you are powerful and that something is happening, and maybe the numbers will be red or yellow or green, depending on if it's a critical hit. Sorry. And it's interesting to realize that the numbers and this blur, this cloud of numbers is the visualization itself. It's something that we wouldn't do, I guess, but in this case it works because it's impressive. So I was talking about data frames. Maybe I should have talked about dashboards. Sports games, in particular simulations, offer you so many possibilities to see the properties, the characteristics of your players, and to optimize the way you build a team. So there's Pro Evolution Soccer here, but there's also a game called FIFA, which is the main game on football, and it led to many people going to big leagues or smaller leagues and observing the players on the field, observing the player practicing, and it led nowadays to a huge industry or market of sports analytics. And it's interesting to see, and we'll go back to that later too, that the development of video games and the need for statistics was accompanied or had an influence on the real life sports. At the beginning of the quarantine, we were talking a lot about electronic sports because people were wanting to see the end of the championship, and they turned to electronic sports to see some action. This is just to have a scatter plot somewhere. Many online games allow you to compare yourself to others. So this is the case here with Rayman Legends, where you can see where you are positioned. This is not my score, of course, where you are positioned compared to the others in the world or in your own country. But still, if you think of scatter plots, you need to, and you don't know anything about data visualization, you need to be able to read the labels, understand what having a point in the middle is, what do the axes mean, what's the scale. And here you have this example of a very, very efficient data visualization. And because they cut a lot of things, and still the point, I mean, there are too many pixels being used in this data visualization, and still it works. So yeah, some lessons which are valid in our world are not valid or not the same in the world of video games. That's one of my favorite games, so maybe I'm biased by bringing it here. It's called TIS 100. And here, in this case, you have open problems to solve by coding in assembly with a network of really limited processors. So assembly is a very old programming language, low-level machine, and at the end, when you launch your code, you can see how efficient your code is compared to the others with these really nice-looking histograms. There are not so many histograms in video games, so I really had to put this screenshot here. And in fact, it worked so well that they've been using histograms in all their games since. This is Shenzhen, which was released 1 year later, and you have Opus Magnum and a few others. If you like puzzle games, which are a bit complicated, and you want to learn about assembly and electronics, they do really interesting games. Yeah, I should go faster. So you have tons of networks in video games, but not, a bit more hidden. Here, if you want to develop in Civilization 3, if you want to develop your civilization in advance, you will need to do it step by step. So this gives you, in fact, the relation, the way to go from one step to the other. We also have in role-playing games the possibility to build social networks. In this case, it's an affinity chart. So there's that. In fact, by reading the network and by gathering information about the people and what the network is supposed to look like, you will infer what are the quests you are supposed to do. So a really interesting thing, and this is a wide question, because people were interested in, when they were making games, to look like reality. Video games were supposed to look like reality, and we have games played in first person from the 70s with games like Star Raiders, and they tried to do that, and it's also something that is being done through photorealistic graphics. I mean, nowadays, when you download a game, it's going to be 100 gigabytes, gigaoctets, and most of it is about the textures. But it's really nice looking, and in some cases, you have things which look like real life. And that's one of the goals of the industry, which is absolutely not followed by the independent developers, but that's another thing. And so they were thinking about it, and they tried to work with a diegetic visualization. So how to put all the information you have inside the game, and taking away the HUD, the heads-up display, so all the information you have on the borders of the screen, to make you more immersed. And this is really useful knowledge, because nowadays with virtual reality, whether it's going to work or not, but it seems to be here to stay, you need to take away all the non-necessary information so that you really feel incorporated into the player. So this is one of the things that the industry is trying to achieve right now. So same character, you see the health bar in the back being lower because he got fired. He took fire. This is sometimes an excuse. This is Titanfall 2. You are inside a mecha, and that's the excuse to put really too much information. But still, it's an interesting take. It works quite well in this game, Metroid Prime, where you are a bounty hunter with a huge combination. And you can see all the information here on the left, on the right. There is a radar on the left. There is the health bar, the ammunitions left in the middle. And this is quite amazing, there is a mini-map on the right, on the top, which is 3-dimensional, and which is really easy to use. And you have kind of a scanner which lets you see all the enemies. So you need to be into the game to use it, but in this case it works quite well. And it's an old game, it's close to 20 years old. So it was really a huge step forward at the time. There is just this little message at the center which ruins, if I may use this word, ruins the whole experience, because you see there is the Z button. It tells you that you have to make a manipulation. So this is non-diegetic. It's something that reminds you that you are a player outside of this universe. Yeah, nowadays you have in the minority report style many visualization of this kind. I will go maybe a bit faster. This was a really great experience with the Wii U. When you wanted to see where you were, or you wanted to open a door, or you wanted to make any actions, you had to lower your eyes and see this little screen, which was also your pad. And the action was still happening on the main screen. So sometimes you were watching the map, and zombies were entering the room and attacking you. So they took advantage of this configuration to really bring interesting experience. Same here with the Nintendo DS, where you have two screens, and each screens have different properties. So they were taking advantage of that too. Still, maps are maybe the visualization the most recurrent in video games. So this is, just to conclude this part, an extract from a screenshot from Beat Saber, which is a virtual reality games where you have two controllers and you have these boxes coming at you, the red boxes, the blue boxes, and you have to break them with your lightsaber in rhythm. So yeah, a nice example. I mean, I think it's maybe the most successful virtual reality game. So it's and it's really well made in terms of immersion. So a nice example of what they are trying to achieve. Okay, so video games have been influenced a lot by cinema in the way they tell stories. I mean, the topics themselves, there were screen adaptation, adaptation of movies really early in the history of video games. Even the first video games like Space War were references to the movies that were popular at the time. And for a long time, video games were borrowing from cinema, but nowadays it's more equal, or maybe even the video games influence in return a bit more cinema because of the special effects, because of computer-assisted graphism in general, but also also thanks to these special effects and all the game engines that are used now for cinema. And this is something which is happening and even more visible with video games and their relations to sports game and sports in general. So here you have this example here of FIFA 2017, where you had the possibility to practice, to follow a story, a really well narrated story of a player, and then to do some practice. And here below on the right, you can see in the screenshot all these lines, all these indicators that the players on the field cannot see, but you can see them and you can understand what you have to do. And from there, the possibilities are quite infinite. Maybe you've seen that on the television when they analyze a game at mid-time, and they annotate. It's more annotation than charts or histograms. But this annotation allow you to understand the dynamics or to remind you of the rules. So here with the augmented reality, they were able to show players during this before this match beginning in Portugal. With tennis, you have this technology being used. I'm late, yeah.
Yeah, Yannick, as you asked me to warn you, just to tell you, we are like it's 20 to 6 now. Okay. But take some minutes to finish, of course.
Yeah. Again, just a few slides. Thank you very much. So this is the same kind of technology which is being used here to in tennis to test if a ball has touched the line. And here, in this funny example of an annotation in a American football match, you have the actual version today, where in football you will have a lot of things which are impressed on the screen, a lot of augmented reality. And it's the same kind of technology, the things that were being done in video games 20 years ago. Another example with sailing here. Okay, so maybe I don't need to spend too much time with that. I find this visualization quite interesting. Here on the right, you have to do, this is Ring Fit. You have to do exercise in order to beat monsters. And here on the right, you can see a belly. And if you do the move right, it turns into that, and then it beats the monster. And this is, I didn't know where to put that in my presentation, but I wanted just to show you the kind of crazy thing you're going to do when you need to communicate the success of the avatar. And this was just a meta thing in TIS 100. Before I show you, this is there is a level where you have to draw a histogram. So yeah, that was just a kind of a geeky conclusion. So thank you very much. I've put some references here, and I'll be happy to share them with you and answer your questions. Thank you.
Yeah, thank you very much, Yannick. Really very, very interesting presentation. Lots of references. It's great. I want to play all those games now.
Really? That's all.
Yeah, so we have a few questions. So I think I will go through them and maybe ask you, rephrase them. So the first question is, who designs these data visualizations in bigger game productions? Are there dedicated practitioners for these components, or is this done by the designers of other aspects of the game experience?
So I think it depends on the size of the team. I don't have a real example, but if the team is small, everybody has to do a lot of things, because to create a game, you have 10, 20, 30 different jobs, and you need to be able to be polyvalent. But when you create a huge game, you will have 4 or 5 people working just on UX, and I don't know if it works in English, but ergonomics. And usually it's somebody who is dedicated to that, and video games rely a lot on quality assistance. It's also it's a job which is well known nowadays because it's really badly paid. But people who are just trying to break games, people who are trying to put themselves in the shoes of others. So it's just it's a linear dependence to the number of people in the team. But in teams, you will have people working only on that.
And do you know maybe also if there is like specific user research on visualizations within games?
Which kind of visualizations? So when I prepared this talk, so as I said, you have people who are trying to make typology or to discuss about what works, what doesn't. I found a report saying that diegetic information is not more useful than non-diegetic information, and I found another report saying exactly the opposite. So I guess it depends a lot on the context. Maybe there's not a final solution, and it's only about the context of your game and testing it, and the audience also. I'm making my kid playing a lot of games I love, and she doesn't play them right. I'm rediscovering the games. In fact, I'm discovering the game design of these games and how perfect they are by seeing her being able to learn or not. I'm a bit out of topic, sorry.
No, it makes sense. Yeah, so like I'm following up on the questions. Do you see trends in game visualizations? And if so, do they interact with, in some way, like follow or prelude trends in the broader data visualization community?
That's a very hey Ralph. That's a very interesting question. So this is, for me, it's I was really happy to be invited, and it's an exploratory work. This is something which needs to be explored much more to be able to make a good answer. From what I observed, you have you often go back. I mean, people test something. There are some kind of fashions, mode. So during a few years, something will be very popular, and we go back to old techniques, etc. So maybe the media is too young to have big trends. I feel like the trends are more linked to the software and I mean to the constraints of the software nowadays, and in the old days of the hardware. So how using Unreal or Unity or any other game engine, so there are softwares or platforms which allow you to create games, these ones and what is being implemented in them is going to define the trends and the games of tomorrow.
How do you imagine the gamification of dashboards for business or day-to-day insights will grow over time with the increase in AI-generated designs?
I need to concentrate. For business or day-to-day insights will grow over time with the increase in... I don't know. I don't know. I really don't know. I'm quite impressed by all the clicker games and all these simulation games, which like if you play Football Manager, it's really not good looking, but people really want to manage teams, football teams, and they go over the design. So and this was about gamification of dashboards for busy. Okay, so I'm a bit of out of topic. Sorry. I'm not sure I understand the. In fact, no. The thing is, I don't know about AI-generated design used for dashboards. So I think I'm not competent to answer the question simply.
Okay. If you want, like the person who asked this question, if you want to, like, maybe rephrase it or elaborate in the chat, maybe it will help the answer. Okay, so let's jump to the next question, if it's okay. Do you see a big difference between console, PC games, and mobile games? It seems that some mobile games are pretty much only data visualization that you can interact with. For instance, Mini Metro.
Yeah, that's a. Thank you very much for the question, for all the questions. Yeah, Mini Metro is a special case. So you need to build a network of metros, and all the design is based on the design you have in some of the metro maps. So this really useful designs with the 45 degrees angles. And this reminds me of, I don't remember where I read that, but one of the articles I used to prepare this talk, in it, somebody was saying in games, all data is visualized or something like that. I mean, everything in the game is data visualized, which is true simply because the games are code, I mean lines of code. Here, this is I don't have a straight answer because it's more there are more like lessons. It's really special cases. When you play Mini Metro on your computer or when you play it on your phone, it's the same game, but it's not the same experience. I mean, everything changes, and even some gameplay elements. And it's even more visible with a game like Fortnite that you can play. You can play it on a huge, big gamer computer, or you can play it on your phone. And it's these. You have the same rules, but it's not the same game. So yeah, I see big differences, and I think it's a bit too reductory. I mean, not all mobile games are only data visualization. If you play Monument Valley or Florence, for example, which are amazing mobile games, which are some of these mobile games which are not PC and console games adapted to mobile games, to mobile phones, but they are games developed really for mobile phones. And in this case, we will discuss that later if you try them. But I think they are really far from this idea of being only data visualization.
Mm-hmm. Yeah, I think the question was also like on mobile, it's mostly data visualization that you can interact with, and maybe like that on console you interact less with the visualization itself. I'm not sure. But yeah, cool. Thank you very much. Another question. There is research into effective displays of information for time-critical tasks. Do you think maybe game viz can help us to design and test with a lot of people more effective visualizations for real world under pressure scenarios such as search and rescue operations?
Yeah, I really think so. You have some serious games being developed. I mean, all the money in science is is used for serious games and understanding how the games work or not. And I don't. Maybe this question has been covered. I know. Yeah, it's still a complicated question. You have to. We do some kind of these serious games where you have to do tasks which have to be as fun as possible, but in fact you're doing scientific tasks behind. And I think it would be interesting to answer your question to go watch what they did in terms of game design, especially since they are addressing their games to thousands and thousands of people. But yet, I'm not sure I'm answering the question. Especially the under pressure scenarios, such as search and rescue operations. So you would the idea is to use video games like when you practice going to space or flying or fighting on the field with the video games. I think. I think my answer is yes.
Like the design of visualizations in games, like influence like real world visualizations, especially in under pressure scenarios. Yeah, it's a very good case. So Ralph, I did a comment. You could test a visualization for Rega pilots with only about 20 pilots in the real world, but you could test it with thousands of people in a helicopter scene.
Okay. Yeah. That's a really good remark. It's you can look at digital labor. It's a keyword for that. How you parallelize some task and see how people behave. In this case, it's still a bit complicated because if you want to test if a visualization work for a helicopter pilot with 2,000 people, you won't find 2,000 people being as competent. I mean, having the same background as the pilot. So I think in some cases there are limits by using the crowd.
Mm-hmm. Okay, we have some more references in the chat also. Thank you, Robert. We have a last question, which is from Ben. Are there examples of intentionally misleading visualizations in games? For instance, in gambling or freemium games to manipulate users into paying?
Yeah, I'm pretty sure there are some. I don't have examples, but and it's not exactly misleading, but all these freemium games, free to play games. So you are free to install and play the game, but you're going to be stuck, and you need to buy stuff to go further. And you buy virtual coins, so you buy the money in game. And in these cases, you always have a few options, and the most expensive one is always a bargain because you spend 10% less. And this is really misleading, and we know it works. So it's not really misleading, but this is really manipulative. And yeah, we know it works. Something really misleading data visualization like we see on Fox News. I don't remember seeing that. But that's a great question. That's something I want to explore now.
Cool, thank you. So we don't have any more questions. So we have 2 minutes left.
I see there are really interesting things happening in the chat.
Yeah.
Can I save it?
Mm-hmm. Yeah. You can have access to it later.
Okay, excellent.
All right, then I think it's already time to wrap up our meetup. So again, thank you very much, Yannick, for the excellent presentation. Really interesting, and thank you also very much for everyone to participate in the event and for being so active in the chat and asking questions. It's great to see that it's so lively. Also, don't hesitate. If you have feedback on on the meetup, on the webinars, and if you have suggestions for improvement, please don't hesitate to reach out to me or Benjamin, either directly on Meetup, or we're also on Twitter and Instagram at DatavisZRH. So really don't hesitate. Also, if you have ideas for topics that you would like to see covered, or ideas for potential speakers, or if you want to speak yourself. Yes, and we have a meetup plan for July. It will be July 16th. It will be about data visualization guidelines in corporate environments. And it will be like a tandem presentation with Sofia Martinovic, who is a visual analyst consultant, and Tanya Boa, who is an interaction designer at Interactive Things. So I hope to see you all there in a month. Yeah, and for now, I'll say goodbye and thank you again, Yannick.
Thank you very much. Thank you everybody for the conversation.